Find the horizontal and vertical asymptotes of each curve. If you have a graphing device, check your work by graphing the curve and estimating the asymptotes. So the first thing is we can determine the vertical asymptotes by observing the denominator. So what we can do is we can set the denominator equal to 0 and solve for x. So we have x squared plus x minus 2, which is equal to 0. So we can factor this to be x minus 1 and x plus 2. So that tells us that our vertical asymptotes are -2 and +1. So now what we're going to do is we want to be able to then find the horizontal asymptote. So if we want to find the horizontal asymptote, we want to find the limit of this function. And the limit of this function as x approaches infinity. So we're going to find the limit of 2x squared plus x minus 1 divided by x squared plus x minus 2. So the first thing we want to do is we want to look at the coefficients, the leading coefficients of each particular numerator and denominator, which is x squared. So what we can do is we can multiply the numerator and denominator by 1 over x squared. So now we end up with the limit as x is approaching infinity. So we get 2x squared over x squared plus x over x squared minus 1 over x squared divided by x squared over x squared plus x over x squared minus 2 over x squared. So now let's go ahead and simplify. So we end up getting 2 plus 1 over x minus 1 over x squared divided by 1 plus 1 over x squared minus 2 over x squared. Okay, now we can evaluate this limit as x is approaching infinity. So when we evaluate, we get 2 plus, well, we can see that this 1 over infinity is going to give us 0. And this 1 over x squared is also going to give us 1 over infinity, which is 0. Over here, this also gives us 0, and this the same, which is 0. So what we end up with is 2 plus 0 minus 0 over 1 plus 0 minus 0, which is equal to 2 over 1, which is equal to 2. So therefore, that's going to tell us that the horizontal asymptote is at y is equal to 2. Now that we have the horizontal asymptote and the vertical asymptotes and we know what our function is, let's go ahead and graph this on Desmos. So let's graph the function 2 x squared plus x minus 1 divided by x squared plus x minus 2. So there's our graph. And now let's go ahead and graph our vertical and horizontal asymptotes. So we have x equals -2. We also have x equals 1. And we also have y is equal to 2. And so therefore that confirms our graphing result with those vertical and horizontal asymptotes. So if we take a look at the first vertical asymptote, we know that this represents x, which is equal to -2. We also know that this represents x is equal to 1. So let's confirm this. Okay, so as the function here, as the limit, as x is approaching -2, then we can see that the limit of this function is going towards positive infinity. And from the left. So as x is approaching -2 from the left, we see that the function is approaching positive infinity. And as the function is approaching -2 from the right, we can see that the function is approaching negative infinity. So that means that you should have a limit that does not exist, which is the vertical asymptote at x equals -2. And likewise over here at x equals 1, we see that as x is approaching 1 from the left, the function is going towards negative infinity. And as x is approaching 1 from the right, the function is approaching positive infinity. So again, that limit does not exist, which is the reason why we have the vertical asymptote at x equals 1.